Hey everyone, I'm sorry I'm not at school today. I wanted to make you a video going over the bell work and going over the notes so that you could still have some actual instruction from me. Um, I'll go over the bell work first. It's all review, so hopefully you don't have a really hard time with it. We'll look really closely at Monday's number one. So I'm going to zoom in. It says write the equation of the line. Okay, so I know it's been a while, but you should be able to remember that to find the slope given a graph. Okay, this is pretty easy. Slope is rise over run. So how much are we rising and how much are we running? Well, you can pick any 2 points where it crosses the grid exactly, but I'll choose the 2 points that are given. We are rising 2 and running 1. So my rise is 2, my run is 1. Okay, so that's my slope. And we've been practicing the y-intercept all week, right? That's the b, the y-intercept. So where does it cross the y-axis? This is my y-axis, right? And it crosses it here at -2. So putting it all together, we put it in slope-intercept form, y equals mx plus b. So slope represents m, right? And so we found out our slope was 2 over 1, which simplifies to 2. So this is y equals 2x, and my b was -2, so plus -2. Y equals 2x minus 2. Column 2 asks for us to write the perpendicular slope of the line. Well, it looks like we have the exact same line here, so that shouldn't be too hard. If our slope, right, our m, was 2, and I'll write it as 2 over 1 just for the sake of finding the perpendicular slope. The perpendicular slope is the negative reciprocal. Okay, so the negative reciprocal of 2 over 1 is negative 1 over 2, right? The reciprocal means we flip the fraction. 2 over 1 becomes 1/2, and the negative reciprocal means whatever sign is there, it changes to the opposite. So if it's positive, it becomes negative. If it's negative, it becomes positive. So the slope, the perpendicular slope, would be negative 1/2. And we can always try that, right, to see if it looks like it makes a perpendicular line. If I were to take any point on this graph, and I'll choose the y-intercept, and I went down 1 over 2, down 1 over 2, down 1 over 2, and I connected those dots, that should look like it connects at a 90-degree angle. And it does. Okay, so column 3, I guess I can zoom out now. Column 3 says to check all relationships between angle 1 and angle 2. So what choices do you have? Are they adjacent? Are they next to each other? Yes. Are they complementary? Put together, do they make 90 degrees? Hopefully you can see that. Right, we have two acute pieces that put together make 90 degrees. Yes. Are they supplementary? Put together, do they make a straight line? No. Are they vertical? Are they the same and across from each other? No. Okay. And here we have column 4. Okay, we're simplifying this expression. Hopefully you remember how to do exponents. We have 4 cubed raised to the power of 2 times 4 to the second divided by 4 cubed. So 4 cubed raised to the power of 2, that means 4 times 4 times 4, right? Twice. So that's times 4 times 4 times 4. Okay, times 4 to the second times 4 times 4, all divided by 4 cubed. 4 times 4 times 4. Okay, well, if we have 3 4s below, we could cancel that with 3 4s above, and we have 4 to the 5th left over. We have 5 4s left. Okay, there is an easier way. If you use MADSEM, we know that if you're multiplying, which we are here, right, we add the exponents. If you're dividing, you subtract. If it's an exponential property, right, which is a power raised to the power, you multiply. So this would be 4 to the 6th times 4 squared, which leaves me with 4 to the 8th, divided by 4 cubed is 4 to the 5th. Okay, so now let's go over your notes. So these notes, the sub should have printed for you. We have parallel lines. Okay, so this is Geometry Nation, Unit 2.6 and 2.7. You can prove theorems about lines and angles. Use theorems about lines and angles to solve problems. Okay, let's do it. I need to turn off my phone because people are texting. I guess I'm in a group chat. Sorry, guys. 8 missed text messages. How annoying. All right. So here we have parallel lines. And parallel lines, you already know, they never cross. Okay, but specifically, parallel lines are two coplanar lines. They lie on the same plane. Two coplanar lines that never intersect. Okay, so what you need to know about that is even if it looks like there's no plane between them, if you have a pair of parallel lines, there can always be a plane between them. So we have two coplanar lines that never intersect. And the way we indicate parallel lines, if we're given a picture, are these arrows here. So arrows are used to indicate that the lines are parallel. Okay, and the notation to write parallel lines is AB, and this is line AB, is parallel to line CD. Okay, so parallel planes are planes that never intersect. And the symbolic notation for parallel planes is just like the symbolic notation for parallel lines, except now we say plane, whatever, plane J is parallel to plane K. Okay, and the reason why we're calling it plane J and plane K is because there's no points on that plane, and we would need 3 non-collinear points to name a plane. So we're just going to call it by the capital letter J and K. And skew lines were introduced last week on Thursday in the scavenger hunt. If you chose that activity, skew lines are non-coplanar lines that never intersect. Non-coplanar lines that never intersect. Okay. So an example would be, well, I'll just show you. If we chose line segment PS, right? And don't draw this on your picture, but for example, PS would never, ever, ever intersect and is not parallel to QU. So those are on completely different planes. They will never intersect. So segment PS and segment QU. Okay, so I'll find another one. How about WV? Segment WV. So on a completely different plane and would never intersect. Can you see any? How about PT? Those two lines would never ever intersect. They're on completely different planes. And why don't you guys find a third example? Because there's lots there. Okay, so I'm going to do example 1, and you guys can do example 2. So example 1 says, name all segments parallel to AE. Okay, so here's AE, and there's lots of segments that are parallel to it. So that would be every vertical line there. We have BF, we have CG, and we have DH. So I'll go ahead and write those down. Segment BF, segment CG, and segment DH. Give 2 examples of parallel planes. All right, well, so they don't have capital letters to name the planes here. We're going to use 3 non-collinear points. So I'll call the bottom plane ABC. So that's plane ABC. And what is that parallel to? Well, that's parallel to the top, EFG. Okay, so what else is parallel? How about AEF, the front plane, the one closest to us? AEF is parallel to DHG. Okay, so now it's asking us to name all the segments that are skew to GH. So GH, oh no, I lost it here. Geometry. Okay, well, this isn't your notes. Delete. Oh, we're back. Okay. All segments skew to GH. Sorry about that, guys. What will never cross GH? Okay, well, we know that everything on the top plane and back plane won't work, right? We can't use EF because EF is parallel. We can't use DC because DC is parallel. And then we can't use anything that crosses it, so these ones are out. Hopefully you can see that. All of the skew ones, and they can't be parallel, so we couldn't choose AB. That would be BF, AE. We could do BC and AD. Right, those would never ever cross. So I'll write all those down. AE, AD, BF, and BC. Okay. So I'll leave you guys example 2, and we'll come over here and talk about transversals. So what is a transversal? A transversal is a line that intersects 2 or more lines. So, for example, we have line L and line M, and it is crossed by the transversal T. So T, line T intersects line L and M. Okay. So corresponding angles are angles on the same side of the transversal and in the same position. So if you're looking at the diagram to the left here, all right, I'll zoom in. We have two lines intersected by the transversal. Hopefully you can see that the two lines are L and M and the transversal is T. Okay, so if we're talking about angles on the same side of the transversal, well, we'll call this transversal, right? This is our transversal T, and this would be the left side of the transversal, and this would be the right side of the transversal. I don't know why I wrote side. I need to write right. So angles on the same side and in the same position. So if it was in the top left, right, that would be angle 1 and angle 5, right? Those are both on the top left of the lines cut by the transversal. So angle 1 and angle 5 are corresponding. I'll write that down. Angle 1 and angle 5 are corresponding. What else? So we'll break it up into sides. So how about the bottom left? The bottom left, 4 and 8, are corresponding. They're on the same side and in the same position. Angle 4 and angle 8. Okay, what else? How about the top right? Top right would be angle 2 and angle 6. And the bottom right, angle 3 and angle 7. I think that covered all of our corresponding angles. Okay, so the alternate interior angles are the interior angles non-adjacent, so not next to, and on opposite sides of the transversal. Okay, so I want you guys to think of this. We still have the left and right side of the transversal, and I'll color this in it pink because I think it helps when you have colors here. My transversal's pink. And if I have two lines and it's asking about the interior would be here, right? Inside the two lines. So this would be the exterior. Anything highlighted is the interior. Hopefully you guys can see that. So interior angles are non-adjacent and on opposite sides of the transversal. Non-adjacent, not next to each other, and on opposite sides of the transversal. But they have to be on the inside. So 4 and 6. Angle 4 and angle 6. They alternate the transversal, they cross over, and they're on the interior. Okay, so what else is alternate interior? 5 and 3. Good. Angle 5 and angle 3. Okay, so if I'm asking about alternate exterior, it's the same concept. Here's my exterior, the exterior of my two lines, and they alternate the transversal. Angle 1 Okay, so they cross over the transversal, and it's on the opposite exterior, alternate exterior, angle 1 and angle 7. So the other one would be angle 2 and angle 8. You got it. Okay, so same side interior angles are interior angles that are on the same side of the transversal. So I'll color in my interior. Here's the interior. Same side of the transversal. 3 and 6. Angle 3 and angle 6. All right, I call them consecutive interior angles. The other one would be angle 4 and angle 5. Okay, consecutive exterior angles. All right, well, I think if I color my exterior, maybe you can see, right? They are on the same side. Angle 2 and angle 7 are on the same side of the transversal and on the exterior. So that's consecutive exterior. Angle 2 and angle 7. And the other one would be angle 1 and angle 8. Okay. So I know that's a lot of info in a short amount of time. If you guys want to go ahead and watch the video for, I believe it's 1.5, 2.5 about angles, I think that's the one that goes with this lesson. And I'll leave you example 3 and do example 4. So they're asking us to write down the angle relationship. If no relationship exists, write none. Okay, so A, 5 and 13. 5 and 13. Okay, well, what transversal do we have? We have transversal B, and they're both above and to the left of C and D. So I would say those are corresponding. Corresponding angles. Okay, how about angle 7 and angle 14? Angle 7 and angle 14. Well, where's our transversal? You have to ask yourself. Our transversal is still B. All right, and it's on the interior of C and D. So these angles are alternate interior angles. All right, 3 and 16. Angle 3 and angle 16. Okay, so you ask yourself, where's my transversal? Well, you can see here, they're both below C and D. They alternate C and D, but there is no actual transversal, right? One's on the interior of C and D, one's on the exterior. They alternate, and there is no transversal. So this one was a trick question. Oh, this one isn't a trick question. Sorry. Look, because I read 16. It's 3 and 6. So where's my transversal? Well, as a matter of fact, I've already highlighted. This transversal is C. Okay, so 3 and 6 are on the exterior of A and B. The transversal is C, and they cross over it. So this is alternate exterior. All right, 9 and 14. 9 and 14. Okay, do they have any line in common? Yep, line D. So line D is the transversal. They're on the same side of the transversal, and that would make A and B the two lines, right? And they're on the exterior of the two lines. So, exterior, same side. You got it. You can call it same side exterior, or you can call it consecutive exterior. All right. 4 and 7. 4 and 7. All right, they're both connected to C. That makes C my transversal. And They're also both attached to A and B, so those are my two lines. And they're on the interior of A and B, right? Same side, interior, right? They're not crossing the transversal, so I would say this is consecutive interior. Angles. All right, 2 and 10. 2 and 10. Okay, what do they have in common? A, right? They're both on the top and right of their lines. They're both on the right-hand side of the transversal. So this is corresponding angles. How about 8 and 14? 8 and 14. What do they have in common? Line B is my transversal. They're on the interior of C and D. They're on the same side. They are consecutive interior. Okay, number 6 and 11. Angle 6 and angle 11. Okay, so this one is the one where you ask yourself, where's the transversal? It can't be C because 11 doesn't touch C. It can't be D because 6 doesn't touch D, or B, or A for that reason, so that one is none. That was a trick question. How about 4 and 13? Angle 4 and angle 13. Where's the transversal? Can't find it? There's no relationship. How about angle 4 and angle 9? Well, hopefully you can see the transversal is A, right? They cross over the transversal. They're on the interior of C and D. Okay, so that makes them alternate interior. Okay. So you guys can do number 3, and we'll come down here and talk more about angles formed by a transversal. All right, and these are angle relationships that once you get the hang of them, it'll be pretty easy. Okay, name that transversal. Angle 1 and angle 12. Okay, so this is angle 1, and this is angle 12. What are they both connected to? Line L, that's the transversal. Okay. Angle 3 and angle 6. Angle 3, angle 6. What are those both connected to? Line J, that's your transversal. Okay. Angle 7 and 15. Those are both connected to line M. That's your transversal. I know you guys are probably getting annoyed. How about 12 and 14? That's line K. Okay, so let's name some corresponding angles. How about if I use M as my transversal? So here's M. This is my transversal now. All right, and it needs to be in the same position and on the same side of the transversal. So I could do angles 13 and corresponding to that would be 5, right? That's on the top left. I could do angle 6 and 14. What about if I made my transversal something else? How about something tricky? What if my transversal was J? Top left is still 1 and 5, right? Angle 1 and angle 5 would be corresponding. I guess that's harder to say. Well, I guess it is left, top and left. How about bottom and right? Angle 4 and angle 8. I'll let you come up with the last one. Okay, so alternate interior angles. Let's go ahead and indicate a transversal. I'll choose L this time. So here's L, my transversal. An alternate interior means they cross over the transversal, but they're on the interior. So here's my interior. Okay, so that would be angle 2 and angle 11. And I could also do angle 4 and angle 9. All right, let's try another one. Let's try K as a transversal this time. K is a transversal. Oh, that wasn't very good. Okay, so now my interior would be here between L and M, right? That's my interior. And it's got a crossover line K. That would be angle 12 and angle 13. Angle 11 and angle 14. Okay, so not too bad. How about alternate exterior? Well, what's the exterior? It really depends on which transversal you choose. So what if I chose M again? M is a transversal. My exterior would be outside J and K, right? And alternate means they cross over. So angle 5 and angle 16. Angle 7 and angle 14. All right, let's choose another transversal. We'll choose K again. So here's my transversal. All right, and exterior. Exterior would be out here and out here. Alternate exterior. So hopefully you're already seeing it. Angle 9 and angle, right, it crosses the transversal. Angle 9 and angle 16. Angle 10 and angle 15. Consecutive interior angles. Same side interior. Okay, so let's choose J. If J is a transversal, this would be the interior. Okay, and same side would have to be angle 4 and 6, angle 3 and 5. I think I'm going to make angle K my other transversal just for saving time. Same side interior, angle 12 and angle 14. The other one would be angle 11 and angle 13. Okay. Last but not least, consecutive exterior angles. I'll choose M as my transversal, and that makes my exterior up here and down here, right? So, same side exterior. If I chose angle 5, consecutive would be angle 14, right? Same side of the transversal. angle 5 and angle 14. Angle 7 and angle 16. What if my other transversal was L? Consecutive exterior. Angle 1 and angle 10. Angle 3 and angle 12. Okay, so what I would like you to do is come up with one more example each and go ahead and give your example to your neighbor, your desk partner, right? And just see what they think. Make sure that that works. Okay, and then finally, non-examples, right? If we have this kind of waffle shape, right? We do. I mean, ours isn't parallel like theirs, but essentially a pound sign. If it is on opposite corners, right? If we don't have a transversal in common, then it's a non-example. So for instance, angle 4 and angle 13, right? There's no transversal there. What if we said angle 7 and angle 10, or even 11 or 12, right? Angle 7 and angle 12 are non-examples because there is no transversal there. Okay, so I know that was a lot. You can always watch Algebra Nation if you're still confused. They have some good videos on this topic. Go ahead and do everything I skipped, and have a good rest of your day. Bye.